So in our last video, we started introducing how to simplify an argument so that we can have an easier time of understanding it when we try to analyze whether or not it's deductive. So hopefully you saw that video so that you understand how categorical claims work and what the standard forms are for categorical claims. And in this video, we'll take a look to use that knowledge and that skill to analyze arguments using the Venn diagram method. Okay, so let's take a look. So as we mentioned in the last video, there are a lot of arguments that can appear to be deductive, where the premises seem to lead to the conclusions, but it's really not the case. That if we take a closer inspection, the premises, because of the way that they're stated, may make us feel like they're deductive when in fact they don't really prove the conclusion that's given. The last two arguments on the list on your screen are examples of that. So what do we do? How do we determine whether or not an argument that sounds deductive is actually deductive? Well, we have a method referred to as the Venn diagram method, where we need to take an argument, put it into a standard syllogism form, standard categorical syllogism form, and we'll use circles, Venn diagrams, to analyze them to see if the conclusions are really necessary given the premises of the argument. Okay, so it sounds like a lot, and in fact it probably is, especially if you're new to analyzing deductive arguments. But stick with it. It's a skill that can be useful, that can help you avoid a lot logical fallacies, that can help you avoid making mistakes in reasoning. Arguments that can sound valid may not be, and we should be careful when we start to take a look at those arguments. So the two things, just to remind ourselves, are one, we need to be able to change claims into standard form categorical claims, and then two, we need to change arguments into categorical syllogisms. As a result, the hope is that you become really good at this. That's going to require some practice, so I'm hoping you take advantage of all the exercises in the textbook. You go through the exercises that we are doing in the videos and try to do them yourselves to get better at this as a skill. This is something that you won't be able to just see once and then do, at least for the most part. It's something that you'll have to practice in order to develop the ability to translate these arguments into the categorical syllogism. It takes time, and the more time you put into it, the more intuitive the process becomes. So our training exercise last video was into turning claims into categorical syllogism, categorical form claims. So as an example, only reptiles can be lizards. That could be translated into our standard A claim form, right? All lizards are reptiles. Now what we'll do is we'll take that skill and apply it to syllogisms, right? Where we take an argument and we put it into the premise-conclusion form that we learned about last video. So the first thing to do is when you're given an argument, make sure you know what the main point is. What is the conclusion that somebody wants us to make? And then identify what are the reasons given. The biggest mistake people are going to make when analyzing arguments in class will be to jump right in to turning claims into standard form claims and then trying to draw the argument before understanding what the argument actually is. So don't do that mistake. Make sure you understand what the conclusion is first, what the premises are first, and then we'll convert them into standard categorical claims, and then we'll draw them. Okay, so identify premises and conclusions. One thing to watch out for is unstated premises. So as you're reading through arguments or as you're trying to listen to somebody present an argument, be sure you're aware of what unstated premises might actually be lurking in the back, right, in the bushes. 3, once we identify what the premises and conclusions are, place them in order. Outline them, premise 1, premise 2, and conclusion, so that we can clearly see the structure of the argument. 4, once you have that structure, then turn all the claims into our standard form categorical claims. Here is an example that we had last time of a categorical syllogism. Premise number one, some lizards are reptiles. So we have two categories there, right? We have a category of lizards and we have a category of reptiles. Second premise, all reptiles are beautiful beasts. Notice our categories. First one is reptiles. The second one is beautiful beasts. What you'll notice about syllogisms is that they only refer to three categories. We're only talking about three things. So the way we describe those categories is that we call them terms. So a syllogism will only have three terms. So when we take a look at our conclusion, it will relate one term to another term that weren't related before. So our conclusion here, hopefully you see, is that some beautiful beasts are lizards. Okay? So this is a standard categorical syllogism. Premise, conclusion. All the claims are in our standard form. So there is an I claim in premise 1. There is an A claim in premise 2. And then we see an I claim in the conclusion. Now, what do you do with this? Okay, so let's take a look at this example and try to turn it into a categorical syllogism. Every cowboy is an American, but I know a few Americans who live overseas. So it's pretty obvious that there are cowboys who don't live here. Lots of ways of saying something, right? You change words, you change the structure of a sentence. Lots of ways of saying the exact same thing. So to make it easier for us to understand it, we want to convert it into something that's familiar, right? So first claim is that every cowboy is an American. Okay, so we'll write that down. The second claim is that I know a few Americans who live overseas. I'm hoping it's obvious to you that the conclusion that this person wants us to make is that there are cowboys who don't live here, right? That's kind of the conclusion that they want us to draw. So now we have the structure of the argument. Every cowboy is an American is a premise. I know a few Americans who live overseas. That's another premise. And the conclusion they want us to make, hey, it's pretty obvious that there are cowboys who don't live here. Now, we want to turn it into a categorical syllogism, meaning we want each of the claims to look like our standard form categorical claim. So, every cowboy is American. What would that translate into? Which of our standard claims, A, E, I, or O, would every cowboy is an American become? Hopefully you notice that it's an A claim, right? We're talking about all cowboys. So in this case, we could say all cowboys are Americans. How about I know a few Americans who live overseas? Now remember, to make it into a standard form claim, we need to identify two groups, two categories, right? Two terms. And we need to identify the type of claim this is. I know a few Americans. Well, that refers to a some claim, doesn't it? Some of something. In this case, some Americans who live overseas. Well, how would you rephrase that second part, who live overseas, into a category? Well, maybe people who live overseas, right? That's a way of categorizing it. So we would rephrase it as some Americans are people who live overseas. So that's our standard I claim. Some things are something else. Some Americans are people who live overseas. So notice that we've identified the phrasing for our three terms. Cowboys is a group, a category. Americans is a group, a category. And then people who live overseas. It's important because now that we've phrased and identified our three terms, we want to make sure that we are consistent so that whenever we're talking about the same group, we use the same terminology, right? So when we take a look at the conclusion, so it's pretty obvious there are cowboys who don't live here. Well, can you restate that as one of our four standard categorical claims? Is it an I? Is it an E? Is it an A? Is it an O? So it's pretty obvious there are cowboys who don't live here. Are they talking about all cowboys? It doesn't say anything about all cowboys. We're talking about some cowboys? Yeah, that's how it's phrased. So it's pretty obvious there are cowboys who don't live here. It's talking about some of them, right? It's talking about some cowboys. So How would we phrase this? How would we phrase, so it's pretty obvious there are cowboys who don't live here. So we know one category is cowboys. We've identified that. What about cowboys who don't live here? What does that mean? Well, that refers to people who live overseas, doesn't it? So we have to be consistent with our phrasing of the term because we can only have 3 terms. So we will rephrase that last claim to say some cowboys are people who live overseas. That's what the last claim means, right? So it's pretty obvious there are cowboys who don't live here means some cowboys are people who live overseas. So now here we have a syllogism, and we've changed each of the claims to be in our categorical claim form, right? Our standard form categorical. It looks like a standard form categorical claim. So this is what we need to do with our arguments, right? We first identify the premises and conclusion. We then change each of the claims into one of our standard form claims. Okay, so let's practice this with another argument. Only those courses that are in the schedule will be offered. Among the courses that will be offered, or among the courses that will not be offered, is History 105, History of Europe. Therefore, History 105 is not in the schedule. I should mention, by the way, that as we practice converting these arguments into a categorical syllogism, we haven't yet decided whether they're valid, right? We're going to analyze them later on. So what you may want to do is put these off to the side or have a separate piece of paper for each of these arguments, and then we'll analyze them using our Venn diagram method later. But the first step, obviously, is to convert all of them into a categorical syllogism first. So here is our argument. Can we identify the structure of the argument? What's the conclusion? What are the premises given? Well, hopefully that therefore gives you a hint, right? The conclusion they want us to draw is that History 105 is not in the schedule. Okay. Well, then that means the premises are given to us in the first 2 sentences. Only those courses that are in the schedule will be offered. That's our first premise. The second premise is the second sentence then, right? Among the courses that will not be offered is History 105, History of Europe. And then the conclusion, as we determined, was that last sentence. Okay, again, lots of ways of phrasing a claim, a belief, right? It can be kind of confusing because we get bogged down in the words and the language. So let's go ahead and simplify the claims now to something more standard. Only those courses that are in the schedule will be offered. Now, can you see what type of claim that is? Is it an A claim, an E claim, an I claim, or no claim? Only those courses that are in the schedule will be offered. Well, doesn't that mean all courses that will be offered are courses in the schedule? Take a second to think about that if it's not obvious, right? Only those courses that are in the schedule will be offered. Only those courses that are in the schedule will be offered. Well, that means that if it's going to be offered, it's in the schedule, right? So all the courses that will be offered are courses in the schedule. Notice the categories, right? We have identified 2 here. One category is courses that will be offered, and then the second category is courses in the schedule. So whenever we mean that category, we have to use that phrasing. Next premise, History 105, History of Europe, will not be offered. Okay, so hopefully you recognize that there's a not in there, so it's going to be an E claim. We're excluding something. Well, what group are we excluding? Well, we're excluding History 105 courses. We're saying, if you want, you could say, no, History 105 courses are courses that will be offered. Therefore, History 105 is not in the schedule. Okay, so hopefully you see the not and realize that it's an E claim. We're excluding a group. Well, which group are we excluding? We're excluding the 105 courses group. We're saying no 105 courses are courses in the schedule. Okay, hopefully that makes some sense on how we translated the original argument into a categorical syllogism. Let's try another one here. You shouldn't give chicken bones to dogs. They could choke on them. So here you see only 2 sentences. can you convert this into a syllogism, given that a syllogism has a premise, and a conclusion? Well, we may need to look for an unstated premise somewhere, don't we? You shouldn't give chicken bones to dogs, they could choke on them. What's the conclusion that they're asking us to draw first? Well, hopefully you recognize that they want us to believe we shouldn't give chicken bones to dogs. That's the conclusion. Well, why not? The reason they give us in the second sentence is that they could choke on them. Dogs could choke on bones. Okay, we know that if it's a syllogism we're after, we need another premise. So can you think of an unstated premise that belongs here? Well, they say they could choke on them. Dogs could choke on bones. Well, we need to relate something having to do with things that you shouldn't give to dogs. So if the premise is that dogs could choke on bones, then the unstated premise is that you shouldn't give dogs anything they can choke on, right? That's kind of implied by the argument. Okay, so there's our first two premises, which leads to the conclusion they want us to draw, that you shouldn't give chicken bones to dogs. So here is the standard syllogism. Now we need to convert it to our standard categorical claim form syllogism. So dog to choke on bones, can you convert that into one of our standard form claims? A claim, E claim, I claim, or O claim. Dogs could choke on bones. How could you convert that? Is it saying something about all of a group? Sure, it's saying something about all chicken bones. It's saying all chicken bones are things dogs can choke on. If that's not very obvious, think about that for a second. Take a moment. When somebody tells you dogs could choke on bones, they're saying, yeah, all chicken bones are things dogs can choke on. Now, if your phrasing is different, if you convert it differently, where a second category maybe is not phrased as things dogs can choke on, but has a similar meaning, then it's fine, right? As long as you're consistent throughout the argument. The second premise, you shouldn't give dogs anything they can choke on. Okay, how could you phrase that? What could be the two categories, the two terms you use here? What type of claim is it? A, E, I, or U? You shouldn't give dogs anything they can choke on. Well, the shouldn't should tell you that it's an exclusion sort of claim, right? We're excluding a group. So that could be converted to no, things dogs could choke on are things you should give to dogs. So the two categories we've labeled here are things dogs can choke on, which comes from things dogs can choke on, which comes from that first premise, right? We already identified that term. And then the second is a newer term that we're making up now, things you should give to dogs. So what we're saying is that no, things dogs should choke on are things you should give to dogs. So those are the two categories for our E claim. Okay. Again, if it's not intuitive, it's something we need to practice going through exercises or watching the videos again. How about the last claim, the conclusion? How could we phrase this, rephrase it, and put it into one of our standard forms? You shouldn't give chicken bones to dogs. Shouldn't. So we're excluding a group, right? Hopefully it's obvious we're looking at an E claim here. The question is, what term are we excluding from what other term? What category are we excluding from what other category? Well, hopefully you can see that you shouldn't give chicken bones to dogs is saying no chicken bones are things you should give to dogs, right? No chicken bones are things you should give dogs. Notice that the two categories, chicken bones, we have already used in the first premise. Things you should give dogs is a category we used in the second premise. So we're consistent with the phrasing. Also remember that for E claims, you could switch the order of the terms, right? And the meaning is still the same. So if you rephrased, you shouldn't give chicken bones to dogs as saying, no things you should give dogs are chicken bones, that's the same thing. That works too. Okay, that's fine. All right. So if it's a little bit overwhelming, you might want to try looking at this again and practice rephrasing the arguments into categorical syllogisms. Now let's move on to our third exercise, the third skill you'll need to have in order to analyze a deductive argument or a apparently deductive argument. The first skill was in transforming a claim into a standard form categorical claim. The second skill was to take an argument and then rephrase it into our standard form categorical syllogisms. Our third skill is now to take that argument, that categorical syllogism, and then draw it. Take the premises, draw the premises using Venn diagrams, and seeing if the Venn diagram you draw shows that the conclusion we're given has to be true. Okay, so it's probably easier just to jump right into an example to take a look at this. Here are the steps, right? 1, translate an argument into categorical syllogism. That was what we learned a second ago. 2, we're going to draw 3 interlocking circles that represent each of the terms. This is similar to what we did in the last video when we drew the Venn diagram for a claim, right? A claim has 2 terms, so we drew 2 interlocking circles. Now, when we take a look at a syllogism, we have 3 terms, so we're going to draw 3 interlocking circles. Then what we're going to do is we're going to shade an X according to the premises. So remember what we learned last time about shading and Xing. We're going to apply that now to a syllogism. The rule, and again I'm going to say this knowing that's going to be much easier to look at an example to make sense of this. The rule is you always shade first. So you take a look at the syllogism, you take a look at the 2 premises, and then you shade based upon the premises. And then after you shade, then you put an X based upon the premises. If both of the areas where an X could go are non-shaded, so you look at the premises, and then based on the premises, you see where an X can go, and it's not obvious because it can go in one region or the next region. It's not too clear. We're going to put the X right on the line in between the 2 possible areas where an X could go. That means maybe X could be here or it could be there. And then once we finish that drawing, we look at the conclusion and we ask ourselves, does this conclusion match what we drew? If it matches what we drew, then we say the conclusion is valid because the conclusion has to be true given the premises. If, when we take a look at the drawing, it doesn't match the conclusion that we're given in the argument, that means the argument isn't deductive. The conclusion does not have to be true given the premises. Lots of words. I know I just spewed out lots of things at you. Best to just do an example. Here we go. Here is the first example we used, right? We came up with this simplified argument. Some Cowboys are Americans. All Cowboys are Americans. Some Americans are people who live overseas. Some Cowboys are people who live overseas. Now remember, the whole point of changing the claims into our standard form categorical claim is to simplify it. So I suggest simplifying these claims even further. Get rid of the words because the words can be confusing, can get in the way of how we think about the logic. Instead, you might want to replace all terms, right, the words, with a letter or 2 to make it more like a math problem. So all Cowboys are Americans, I will simplify into all CRA. Some Americans are people who live overseas. I'll rewrite that and simplify it as some ARO. Some Cowboys are people who live overseas. I will rewrite that. And remember, we have to be consistent with how we label our categories. So I will rewrite that as some CRO. Okay, so 3 terms, CAO, and you can see the syllogism. We get rid of the terminology, get rid of the words to prevent the meaning from clouding how we analyze the argument. And instead, we'll just do this very mechanically. 3 interlocking circles, 1 representing our C group, 1 representing our A group, 1 representing our O group. Okay, so here's our C group, our Cowboys. Here is our A group, our Americans, and here is our O group, our people who live overseas group. Now, for all of these syllogisms, for all of these categorical syllogisms, you'll always draw these three circles in this way, where they all overlap each other, okay? They are all going to mean different things depending on the argument, right? We could be talking about chicken bones later, or we could be talking about classes that are offered later, but anytime you have a syllogism, when we draw the Venn diagram, it's always going to look like this first. Always three circles that are overlapping. Where's the cursor? Always three circles that are overlapping. And I want you to draw them always in this way, right? One group, second group, third group. If you draw it correctly, then you'll notice that there are 7 different areas or regions here, right? 7 different regions. I labeled them for you so that's easier for us to discuss what to shade, what to X, what not to shade, where not to put the X. Okay, so first thing, we take a look at the first premise. All C are A. Okay, so we hopefully from our previous lecture can draw this. All C are A. So here is our C. Here is our A's. To say all C's are A's means that there are no C's that are not A's, right? The only C's that exist, the only Cowboys that exist are the ones that are Americans. Now remember the rule for shading. We shade out the region that does not exist. We shade out the group where there are no members. So if all Cowboys, or is the cursor, all Cowboys are Americans, then the only groups that exist are 2 and 5. Those are the only groups where we have Cowboys that are Americans, which means 1 and 4 don't exist. There are no Cowboys who are not American. So we shade out 1 and 4. The second premise, some A are O. Okay, so here is our A group, our Americans. Here's our O group, people who live overseas. And we're told some A are O. So remember the rule for some claims. We X where there's at least one member. To say some A are O means that we need to put an X either in 5 or 6, right? Because we know there's at least one member of A that's also an O. But it's not clear whether the X goes in 5 or in 6. So what do we do? Well, the rule says if it's not clear in which section should go into, we put the X right on the line in between. That means maybe. It might be in 5, it might be in 6. It's not too clear. That's what the X on the line means. Okay? Now, remember the rule about what to do first. We shade first before we X. So if we take a look at these two claims, the A claim is a shading claim, right? The sum claim is an X claim, so we should have drawn the A claim first, which is what we did. If you have these claims reversed, like the order reversed, then you just have to remember, okay, I need to look for a claim that shades and do that first, and then I do the claim that X's later, right, last. Okay, so now we've drawn the premises. The question is, does this drawing match the conclusion? Okay, let's take a look at the conclusion. Some C are O. There's our C claim. Our C group, our C category. Here's our O category. If I'm going to say some C are O, where does the X have to be? Remember, we put the X where we know there's at least one member. That means the X has to be in 5, right? Because that is the section where C and O overlap. The only sections remaining for C are 2 and 5. But when we are told some C are O, that means there's at least one member of C that's also an O. So that goes into, I'm pointing, you can't see where I'm pointing. It goes into section 5. That's the only section where there is some C that are O. But look where the X is. The X is not in section 5. The X is right in between, which means it could be in 5 and it could be in 6. We're not too sure. Which means the conclusion does not have to be true. If the conclusion had to be true, the X would for sure be in 5. As it's drawn, we don't know if the X is in 5 because it could be in 6. That means this argument is not valid. It is not a valid deductive argument. The premises do not conclude for sure that the conclusion is true. Okay? Let's try another one. So we looked at this argument earlier. All courses that will be offered are courses in the schedule. No History 105 courses are courses that will be offered. Therefore, no History 105 courses are courses in the schedule. Lots of words, right? The goal is to simplify, to make it easier to see. So let's go ahead and simplify using letters. So we have an A claim to begin with. All O's, courses that will be offered, are S's, courses in the schedule. Isn't it much easier to just rewrite it to be all ORS? How about the second premise? No History 105 courses are courses that will be offered. Well, let's rewrite that as no HRO. And again, you could label these any way you like as long as you're consistent throughout your argument. No HRO. So now we have our three terms, right? O's, S's, and H's. So we need to use them again when we rewrite the third claim, the conclusion. Therefore, no History 105 courses are S, courses in the schedule. Okay, so we've rephrased or rewritten our categorical syllogism into a categorical syllogism with just letters to make it super simple. Don't let the words and the long strings of words get in the way of us understanding the argument. Let's now treat it like a math problem. All O's are S, no H are O's, no H's are S's. We're going to draw our three interlocking circles, just like we did in the previous example. It's going to look exactly the same, right? Now the categories are different, though. So we have an O category, right, an O term. We have an S category. There's our S circle. And then our H category, okay? Same 7 sections. Now we have to shade an X. Take a look. There is an all claim, an A claim, and a no claim, an E claim. Both are shading claims, so we have to worry about Xing anything. The order in which we shade doesn't matter. So all O's are S. So here's our O's. Here's our S's. We know that all O's are S. So 2 and 5 exist, right? All the O's are S's. So 2 and 5 exists. But there are no 1s and 4s because 1s and 4s are O's that are not S's. Those don't exist because the first claim says all O's must be S's, right? So only 2 and 5 exist. That means we get rid of 1 and 4. No H's are O's. Okay, so here is our H's. Here is our O's. So if we say all H's are O's, what does it say about the H's? Well, it says none of them are O's. So 6 and 7 exist, right? 5, however, does not exist because we are told no H's are O's. So none of the H's are also O's. So there is no section 5. That does not exist. So we gray that out. Now we take a look at the conclusion and we see if the conclusion matches what we just drew. The conclusion is no H's are S's. You take a look at the H's. Does the drawing say that none of the H's are S's? Well, no, the drawing doesn't say that, right? Because if it were to say that, then 6 would be gone too. 6 would have to be X'd out. But in our drawing of the premises, there's a possibility that 6 still remains, that there could be H's that are S's. So the conclusion in the argument may not be true. There's not enough evidence given to us to show that History 105 that there are no History 105 courses in the schedule. So it's not a valid argument. Can you see how we can be fooled based upon the premises given in the original argument to think, oh, okay, maybe it's true then that there are no History 105 courses in the schedule, when in fact that's not what the premises tell us, right? So drawing it in this way graphically can make it a little bit clearer when an argument is actually deductive, when the conclusion really has to be true given the premises. Let's take a look at one more example. All chicken bones are things dogs can choke on. No things dogs can choke on are things you should give to dogs. So no chicken bones are things you should give to dogs. Lots of words with dogs and bones in it. Let's simplify the argument into just some abbreviations or letters. So all chicken bones are things dogs can choke on. I'll simplify into all B are C. No dogs or no things dogs can choke on are things you should give to dogs. Let's simplify that to no C are G. Doesn't that feel easier to relate to already, right? Doesn't that tend to breathe a little easier now that you see just no CRG instead of that whole sentence there? And then the conclusion, no chicken bones are things you should give to dogs, so no B R G. Okay, our three terms, B, C, G. We have to be consistent, so when we rewrite our conclusion, we use B and G again. Okay, so let's draw this. Notice the premises. We have an A claim and an E claim, so they're shading premises. So you don't have to worry about Xing. So let's go ahead and draw our circles. Just like before, it'll look like three interlocking circles, same shape. Our same three sections. We have 1, 2, 3, 4, 5, 6, 7. Let's take a look at our first premise. All B are C. So all B's are C's means that 2 and 5 exist, right? All the B's have to be C's. There are no 1s and 4s. Those groups don't exist because those are outside of the C circle. Given the first premise, all B's are C's, we know that every B has to also be a C. That means 2 and 5. 1 and 4 doesn't exist because those are outside C. Those are things that are B's that are not C's. So you have to get rid of them, right? The only B's that exist are also C's. So 2 and 5 exists. How about no C's are G's? Okay, so here's our C circle. No C's are G's. Here's our G circle. Saying no C's are G's means that there are no 5 and 6s, right? Those two groups do not exist because we're told there are no C's that are also G's. So we get rid of 5 and 6. Okay, given the premises, this is our drawing. Let's take a look at the conclusion to see if the conclusion has to be true given the drawing, right? If the conclusion looks like what we've drawn. The conclusion is there are no B's that are G's. There are no B or G. Take a look at B's. Are there any B's that are G's? No. There are no B's that are also G's, right? The only B's left is section 2. There are no B's that are also G's. So now we have a valid conclusion. We have a valid deductive argument. The premises actually do lead to the conclusion. What we've drawn is the conclusion. The conclusion matches what we've drawn. Okay, that's how you use the Venn diagram method to verify the validity of a deductive argument. A little bit overwhelming, I bet, if this is the first time you've gone through learning this method, right? So that's why the previous exercise was so important. We first have to get the skill of translating a claim into one of our standard form claims. We then have to have the skill of looking at an argument and trying to reframe it to look like a categorical syllogism. And then our third skill is being able to take a categorical syllogism and then drawing the premises so that we can verify if or whether the conclusion has to be true. So when I said you'll be becoming critical thinking ninjas, I'm not joking, all right? Ninja training is hard. It takes a lot of practice. It takes a lot of skill. Once you master it, you'll be able to slice and dice arguments to be able to tell whether or not they're valid and invalid. You'll be able to tell whether or not what somebody's telling you is actually a conclusion that has to be drawn or just something that's implied. If this isn't very intuitive yet, don't fret, right? We have more practice through homework and through these possible exercises. Take a look at these exercises, these arguments, and what I want you to do is reframe them rewrite them into categorical syllogisms, then take the categorical syllogisms and apply our Venn diagram method to verify whether or not those arguments are valid. Okay? This will be part of our next video. So I am literally going to stop here so that you have time to look at these arguments, rewrite them, do the test yourself, and see if you can verify if these are valid arguments. Then move on to the next video and check to see how well you did. One caveat. When you draw your diagram, it could very well be that your diagram is a mirror or a rotated version of what you'll see in my answers. That's perfectly fine, right? Because the way you label the circles could be different than the way I labeled them. You could have one term first, well, I put it second in terms of where they are in the Venn diagram. What's important is that they say the same thing. So you take a look at your diagram, it should look like a version of mine. The sections that are shaded should represent the sections that I shade in my diagram. Okay? So good luck as you try to practice this Venn diagram method of deductive argument analysis. And you know, just with regular ninja trading, there might be some bruises and some scars along the way, but persevere, stick through it, and you'll be better off at the other end.